Hey everybody, how do we make MIDI work more like music? That's the question I've been thinking about this summer, and I'd like to show you the first results. I've created this spiccato strings template, which I believe is the most advanced workflow yet demonstrated. Now, most advanced is a bold claim, because we've all seen there are A-list composers who have very generously shared their workflows with us online, and we've all seen that they have these gigantic Cubase and Logic templates with thousands of tracks, so that they can put one articulation from each library on each track and have all of their articulations at their fingertips. By contrast, in this spiccato strings template, you can see that I just have 6 tracks: violins, violas, cellos, basses, and 2 more tracks if I want to divide the violins. So how can this workflow possibly compete with what the A-list composers have demonstrated? The answer is that I have my plugin that I've been working on, working in the background, and it's doing dynamic equalization between libraries, which lets me, in a way, think beyond libraries and go back to thinking about notes on paper, or the virtual equivalent. Now, this concept of dynamic equalization is a little bit tricky because it's not dynamic equalization of volume or of audio frequencies, it's dynamic equalization of musical content. There's no other plugin that does this yet, so let me quickly explain what it is and what problem it's solving, and then we can come back and see it in action. Okay, composers who bought libraries from different developers want all of their libraries to work together and feel like they're part of the same recording session. So to demonstrate how that might work, here's a melody that I've divided into 6 pieces and assigned to 6 different French horn instruments from different developers. Let's listen. Okay, that works pretty well. What you probably immediately realize is that each of these instruments requires very different starting volume instructions in order to sound balanced. That's because sample library developers can't agree on a universal or standard volume reference for their libraries, which means that some libraries are much too loud or much too quiet out of the box and need to have their faders moved in order to sound balanced. Now, if you've seen the workflows demonstrated online by composers like Junkie Excel, Tom Holkenborg, or Jason Graves, or John Powell, it's very clear that they've put a lot of effort into adjusting these volumes so that their libraries actually sound like they're being recorded in the same space, in the same recording session. What you possibly didn't guess is the mod wheel, or CC1, values that had to be given to these 6 different French horns. I mean, they're all playing the same dynamic, mezzo forte, so how different can the mod wheel instructions be? The answer is that they literally span the entire mod wheel, from all the way down at the bottom near 0 to all the way at the top at 127. Now, how can this be? How can there be such crazy variety when we're trying to get these 6 French horns to play the same melody? The answer is that if you picture the true dynamic range of an instrument as being a spectrum, like let's say a metaphor, a rainbow, with red being pianissimo and purple being triple forte. Some sample library developers sample from orange to blue, others sample from green to purple, others only sample from red to yellow. And regardless of what they sample, they will always put the lowest layer at 0 and the highest layer, whatever it is, at 127. And that's how you end up with the same dynamic having 6 different assignments on the mod wheel for 6 different instruments. So why do we care about these sort of fidgety differences in dynamic programming between libraries? Well, because they create some big issues for composers. The first one is that MIDI is not portable between libraries. So let's say that you've written something amazing with one string library and you want to try it out with a different string library from a different developer, just to see if the musical mood and tone matches more closely with what you're trying to write. Well, you can't do that because the libraries are completely programmed differently. And the best way to demonstrate that is if we take these 6 MIDI regions which I've created and simply reassign them among the instruments. Remember, we're not rewriting, we're not adjusting the MIDI, we're just assigning it to different instruments. But let's listen. That's pretty ridiculous. I mean, the instruments are playing completely different dynamics now, and we've completely wrecked the carefully programmed dynamic unity from earlier. So that shows how MIDI is not portable between libraries. This problem also crops up when you try to layer instruments from different developers, such as like string libraries or brass libraries, because a kind of a tricky issue arises here. If we continue our color metaphor from earlier, and we say that like one MIDI instruction yields a red, yellow, and green from 3 different libraries, the problem is not just that we don't have the 3 libraries playing the same dynamic. The problem is that green is not only more intense than red and yellow, it's also louder than red and yellow, and so it will naturally dominate. And you'll be drowning out your other libraries with the library that's playing, whatever library is playing the loudest dynamic will naturally drown out the other libraries. And so when you're trying to layer your instruments to create a unique tone or a unique ambience or whatever you're trying to do, those balances are completely unreliable because of the inherent differences in the dynamic programming of your libraries. And the last problem is kind of like a technical one. These huge dynamic differences can make it more difficult to figure out the proper volume adjustments in the first place. So the solution to all three of these issues is to create the plugin that I've created, which lets you program one MIDI instruction which represents your actual musical intention. So for here, we'll program 64 on the mod wheel, that's mezzo forte. And then it translates that into the technical instruction that's needed to be received by each of these 6 different libraries. So you have one MIDI instruction, one musical intention, and you get the same dynamic, the same musical result back from all of your different libraries. So that's what I've done with my string spiccato template. So let's go back to that now and take a look at it. Okay, so here's my spiccato strings template. And I have 4 tracks for violins, violas, cellos, and basses. Now each track is actually controlling 6 libraries in the background, but they're dynamically balanced so that when I play one note, whether it's loud or quiet, I'm actually getting back the same dynamic from all 6 libraries. So let's hear what that can do with all the strings playing together. That's pretty good. So here's how it works. Between these 6 libraries, I have 17 microphone positions loaded up, which are available in the mix console here. So this is kind of an ambition to get close to the sound of Hans Zimmer's private strings library, which famously has like 30 or 35, some crazy number of microphone positions. Here I have 17 loaded up. And they're grouped into 8 groups: spot, close, tree, hall, far, wide, ambient, and surround. And that's based on distance, of course. So microphones from different libraries are flowing into the same group. So all the tree microphones are grouped in the tree group. Now, something that's very important is that these are not buses that you see here, because if they were, I wouldn't be able, the violins, violas, cellos, and basses would all get grouped together. The sound would flow into one bus, and I wouldn't be able to separate them later to print stems. So what these actually are sort of locked-on faders, or VCA faders, I think is the right term, where if you raise and lower one, you can see it's actually adjusting these 5 buses that are actually going to the stems. So busing and mixing are kind of like 2 separate domains here. And this is how I'm able to control all of the sound coming from one microphone while still keeping my 5 string sections separate. Because what happens after they hit those buses that you just saw is they go to the stems, where I'm able to print violin, viola, cello, and bass separately, or as I'm doing right now, a high section and a low section, where the violins and the violas are baked together and the cellos and the basses are baked together. But those 8, we're still printing 8 stems for each group based on those 8 distances. So we can listen to, for instance, just the tree microphones if we want to, which I'll do now. Or the ambient microphones, or even the spot microphones. And it's the sound of all those 8 distance groups coming together that really creates that sort of 3-dimensional sound where I'm trying to replicate the sound of a recording session. Okay, I hope I was able to explain clearly that these faders in the mix console are kind of like they're supervising the buses as they're flowing independently to their stems. So what that lets me do in plain English is raise and lower one mic position of one library at the same time for all the different string sections. And so that lets me really think beyond libraries and go back to thinking in terms of notes, the compositional stage, and microphones, the mixing stage. And as we're about to do some live mixing here, what I'd like you to notice is that as we phase between libraries and different microphone positions of different libraries, the dynamics stay the same. The performed music stays the same because all of these different libraries are yielding the same dynamics back from the same MIDI instruction that we sent them. So that's how we're able to get all of these libraries on the same page with just 4 MIDI tracks instead of the thousands of tracks approach of other templates. So here's, let's just skip the idea of me coming up with some great music and borrow something that Hans Zimmer wrote. This is the Da Vinci Code. Okay, and so now we're going to do some mixing. So I listened to the score. I'm not going to post it here now, but I think the sound is a bit more ambient, deep, less wide, and possibly the close sound, there's still presence, but it's possibly built up out of like the spots and less out of the tree. So I'm going to try and recreate that right now. In addition, I'm also going to take down the trailer string sound because they're recorded in an arc, a centrally seated arc, and I kind of want the violins and violas to have more separation. I'll also, I think, take down cinematic studio strings a bit because they're a bit more bitey in their spiccatos, and mural strings are a bit more feathery. So I'll try and emphasize that sound a little bit more. I think that's good. I'm definitely no Alan Meyerson, okay, so I'm sure that a professional mixer could create much better results, but here's what I ended up with. We can compare that to the original sound. So once you start thinking beyond libraries and you start thinking about notes and microphones, the sound combinations you can get really, really creative with this kind of thing. So here's my trailer brass template, still very much a work in progress, but you can see, similarly to the strings, I don't have 1,000 tracks and a whole folder of brass. I have these pre-orchestrated tracks, epic horns, 2D horns, duets, sustains, and then the same thing for trombones, basically different size ensembles, and then different orchestrations of low brass. And so in 17, 15, something like that, tracks, I have all the brass that I'll ever need. The way it works is very similarly to the strings that I showed you. Now this is still a work in progress, so it probably won't sound as great. But basically I have a whole bunch of different libraries in here, which I can play together if I wanted to. But I probably wouldn't do that. What I'll do instead is basically pull up and down microphones based on the sound I want to create. So let's pull up the Hollywood brass, which is just one microphone position. Now that's a cool sound, but rather dry, so I'll try and put behind it the sound of Berlin brass. I'll pull up those microphones. I'll probably even pull down the Hollywood mic a little bit. And now I've got this awesome legato sound from Hollywood brass, and then behind it, the bells up Berlin sound, which adds a little bit of bite and also puts our sound basically into tel decks. Now we could take that sound and completely change it by instead using trailer brass as our basic sound, which sounds like this. Kind of this wild sound, and then to make it even more fierce, we're going to pull up the spot mics of Jasper Blunk's Bells Up Brass. That's cool. And then I'm actually going to make it more present, but then also include the ambiances from Berlin. Which creates this great sound where we really have the sound of the French horns rasping, but also the sound behind them of the hall. And so you can see that's a completely different sound from the sound we created from Hollywood and Berlin, where we could do cinebrass and something else, or we could do whatever we want. And the important thing is that all you have to do really is record the MIDI once, because the MIDI records your musical intention. Whatever position the module is equals an actual dynamic. And then when you get to the mixing stage, you can pull up and down whatever libraries you want, and the music will stay the same while the sound changes. So that really demonstrates the potential of this technology. And I'm going to keep working on it, and I hope to have more cool things to share with you guys soon. So take care for now.